Okay, here is D-ribose with Mazer's makeshift whiteboard here. And so we know D-ribose, he's the right side sugar. We know he's D-ribose because we look at this particular chiral carbon, the one farthest from the carbonyl carbon, and with the OH on the right, he is D. So this is D-ribose, the right side sugar. So how many chiral carbons are there in here? Well, the first one, of course, is not chiral because he's not sp3 hybridized. The final one is not chiral because he's got two of the same groups attached. But this guy has an O, an H, an aldehyde carbon, and a not an aldehyde carbon, so 4 different groups. He has 2 carbons ending in an aldehyde, 2 carbons ending in not an aldehyde, an O and an H, so he's chiral. And he's got a CH2OH and a 3-carbon chain ending in an aldehyde, an O and an H, 4 different groups. He's chiral. So carbon 2, carbon 3, and carbon 4 are all chiral carbons. Carbon 1 and carbon 5 are not. So let's determine the chirality of carbon number 2. Well, we know that the H is priority 4. Because he only weighs 1, he's always the final priority. Oxygen at 16 is going to be either of these carbons, because I only go out 1 bond for the first cut. So at 16, he's priority number 1. He's the heaviest atom attached to our chiral carbon. But then the question becomes, does the carbon above him win, or does the carbon below him win? Well, remember, when you have a double bonded oxygen, you count it twice. So that's 16, 16, and 1. This carbon is attached to 33 atomic mass units if I only go out 1 bond. This carbon is attached to hydrogen, oxygen, and carbon. So that's 1 plus 12 plus 16. So he's attached to 29 atomic mass units. 33 is more than 29, so this is our second priority group, and this is our third priority group. Now, don't forget, in Fisher projection, horizontal bonds are coming out towards you. So we are looking at this backwards because our lowest priority group is coming towards us. So we look, we see 1, 2, 3. That's going in a counterclockwise direction. But we're looking at things backwards because the lowest priority group is coming towards us. So we reverse the rule, making counterclockwise R.